I now move to a characterization of the number e, and in this case we are going to start with g of x equal to ln x. We are going to start with the natural logarithmic function, and we know that this is differentiable, and g prime x is equal to 1 by x. From this I can write g prime 1 is equal to 1. Now what I do is I use the definition of g prime 1 given the fact that g of x is equal to ln x, and also I can write 1 is equal to g prime 1, and now I use the definition of g prime 1. That means I can write limit h tending to 0 ln, instead of x plus h I write 1 plus h minus ln x, and now I write ln 1 divided by h. Since ln 1 is 0, I can ignore that and I can write limit h tending to 0 1 by h ln 1 plus h, and this can then be written as limit h tending to 0. We can use the rules for ln, and we can write ln 1 plus h raised to the power 1 by h. So what we see here is that limit h tending to 0 ln 1 plus h raised to the power 1 by h, this is equal to 1. And that just means that ln 1 plus h raised to the power 1 by h, this tends to 1 as h tends to 0. Since I know that ln e is equal to 1, e raised to the power 1 is equal to e, that just means I can write 1 plus h raised to the power 1 by h. This tends to e as h tends to 0. And that means I can write limit, or in other words, I can write e is equal to limit h tending to 0 1 plus h raised to the power 1 by h. If I take a look at a table and I write h being equal to first 1, and then I take a look at what is 1 plus h raised to the power 1 by h. I have to move closer and closer to 0, so I start with 1, and that means I have 1 plus 1 raised to the power 1, that is 2 raised to the power 1, that is 2. If h is, so I have to move closer to 0, so now I take h as 1 by 2. If I take h as 1 by 2 and I use calculator, I see that 1 plus h raised to the power 1 by h will be 2.25. If I now go for 1 by 10, if I take h as 1 by 10, 1 plus h raised to the power 1 by h will turn out to be 2.5937, and it goes on. If I go for 1 by 1000, I have 2.7169, and it goes on. If I take 1 by 1 lakh, so there are 5 zeros now, and then it will be 2.71825, and it goes on. If I take 1 by 1,000,000, that means I take 10 lakh, so that will be 2.71828 to 8, and it goes on. Basically, I can see that as h tends to 0, this expression 1 plus h raised to the power 1 by h, it tends to e. And the point to note here is, if I just write this again, limit h tending to 0, 1 plus h raised to the power h raised to the power 1 by h, this is equal to e. So we are actually, if I look at this table, we are getting a closer and closer approximation to e when we choose h to be smaller and smaller. We choose h to be very close to 0. And here, if I let h equal to 1 by n, and h tends to 0, wherein n is a natural number, that means this natural number n is actually going to become really large, because if h tends to 0, n is going to tend to infinity. The natural number n will tend to infinity. Given that, I can now write limit, instead of h tending to 0, I can now write n tending to infinity. 1 plus, instead of h, I write 1 by n. And now instead of 1 by h, I write n. So that means I have this. This is going to prove very useful later, that e is actually equal to limit n tending to infinity 1 plus 1 by n raised to the power n, or if I put 1 by n as h, I can write e as the limit h tending to 0, 1 plus h raised to the power 1 by h.